Welcome to Summarize Science. We often think that to get smarter, we should tackle harder and harder problems, like a weightlifter lifting heavier weights. But does the same no pain, no gain logic apply to artificial intelligence? A fascinating new paper explores this very question, and the answer is not what you'd expect. For a while now, researchers have been debating whether it's better to train AI on easy data or hard data to make it smarter. Some studies suggest easy data is surprisingly effective, while others argue that hard data is key. This study goes deeper by looking at the entire spectrum of difficulty, not just easy versus hard. They want to know if an AI trained on easy questions can solve hard ones, and if an AI trained on hard questions can still handle the easy stuff. A crucial first step was to figure out what's actually hard for an AI, because it's very different from what's hard for a human. For example, this chart on the left shows that the number of reasoning steps a human needs doesn't neatly line up with the AI's difficulty score. A problem we might find simple could be incredibly tricky for an AI, and vice versa. This proves our human intuition about difficulty doesn't really apply to these complex models. The researchers then ran their main experiment. They trained an AI on questions from one specific difficulty level, and then tested its performance on all the others. The results are shown in these colorful heat maps, and they tell a very clear story. In these charts, blue means the AI got better after training, while red means it actually got worse than before. Just look at how the strong blue colors are all clustered along the diagonal. This means the AI only really improved on questions that were about as hard as the ones it was trained on. When the AI was trained only on the easiest problems, it completely failed to get better at the hardest ones. And here's the biggest shock. When it was trained only on the hardest problems, it often got worse at solving the easy ones. It's like a brilliant physicist forgetting how to do basic arithmetic. This directly challenges the common assumption that just throwing difficult data at an AI will make it an all-around genius. The AI's ability to learn seems to be narrowly focused on the specific difficulty it's exposed to. So, let's recap the important takeaways. First, AI models show surprisingly weak generalization across different levels of difficulty. Training on one end of the spectrum, whether easy or hard, doesn't transfer well to the other end. Second, difficulty is relative. What's hard for an AI isn't what's hard for us. This has huge implications for the future. It means that to build truly robust and reliable AI, we can't just test it on the hardest problems. We need to evaluate it across a wide range of difficulties. Future AI training might need to look less like a random data dump and more like a carefully designed school curriculum, guiding the AI from simple concepts to more complex ones. Thanks for watching Summarize Science.